these three cups are in thermal equilibrium. I can measure the temperature in all three mugs here with a thermometer, and you can see that they all come up as being the same temperature. I could also use three different thermometers and they would still say that the temperature is the same across all three containers. That's because temperature is a fundamental and measurable property of matter. The framework that describes all of thermodynamics can be summed up in the 4 laws. And these describe heat, energy, and their interactions with matter. While the first, second, and third laws of thermodynamics are quite well known, there's actually a 4th law that underpins all of the other laws. It was devised after the first 3 laws, but it was so fundamental and provided such a basis for the other laws that it was termed the Zeroth law of thermodynamics. The Zeroth law of thermodynamics is actually an observation and states that if 2 thermodynamic systems are in thermal equilibrium with a third system, they are also in thermal equilibrium with each other. Or to put it mathematically, if A equals C and B equals C, then A must also equal B. If all of these 3 glasses are at thermal equilibrium, then we can say that they're all at the same temperature. And this is where the significance of the Zeroth law lies. It lets us establish temperature as a measurable and universal property of matter. If something is measurable, then we can create scales for it, and that's exactly what happened with temperature. The first temperature scale that, in a slightly altered form, is still in use today, was established by Daniel Gabriel Fahrenheit in 1724. A more common scale, named after Swedish scientist Anders Celsius, uses the freezing point of water as the 0 point on the scale and the boiling point of water as 100th degree on the scale. Rather than using a scale where 0 is defined arbitrarily, what we really want is to use a scale where 0 is the coldest temperature you could ever get to. Scientists around the world use the Kelvin scale, where 0 is defined as absolute 0. Absolute 0 is something that's defined by the 3rd law of thermodynamics, but that's something that we'll get to in another video. Now, it was observed that the properties of matter could change with temperature. For example, liquids can expand or contract when heated or cooled, and the conductivity of different wires can change as a function of temperature. Some old-fashioned thermometers, such as this one, use the expansion of mercury or other liquids under heat as a measuring tool. Modern electronic thermometers, such as these ones, commonly use thermoresistors, where the resistance of a material changes with changes in temperatures. Yet another way of looking at temperature is using a thermal imaging camera. All objects above absolute 0 radiate some sort of infrared frequency radiation, with hotter objects radiating higher amounts of infrared. This allows us to use thermal imaging to see the world, even without any visible light. Now, if 2 objects at different temperatures are brought into contact with each other, then they'll try to reach thermal equilibrium. If the 2 objects are of sufficiently different temperatures, then the reaction can be rather violent due to a phenomenon called thermal shock, because the heat gradient makes the glass want to expand, but the other side is cold. This causes a strain that breaks the glass. The concept of the Zeroth law of thermodynamics may seem trivial, but it lets us define temperature, and that in turn allows us to quantify the effects of the other 3 laws.